Hi, this is Gabriel, and what I would like you to do right now is to sign into YouTube so that if you like this channel and you're like, oh dang, this is pretty good, I want you to subscribe to this channel and you're not all like, I have to sign in and I just have to hit the subscribe button. All you have to do is just hit subscribe and you're subscribed. That will save you hundreds of milliseconds. So I want you to watch this channel from beginning to end so that you get the most out of this walkthrough.
Hi, this is Gabriel, and today we're going to do another walkthrough of this problem, which is an optimization problem. The problem says this: find two numbers whose difference is 144 and whose product is a minimum. We're going to come up with two formulas first, which is a difference formula. So the difference of any two numbers is x minus y, and the product of two numbers is x times y. And I'm just calling this formula D and this formula P for product, D for difference. Now, they're going to give you some type of information, like 144, and that's important to you because that's going to let you know two things. One is, if that 144 goes to this formula, which it does, in our case, this number goes into the D because that's the difference of the two numbers. In other words, if I subtract x minus y, I should get a difference of 144. Now, that's very significant. That lets you know two things. One is you need to rewrite. You need to rewrite this formula in terms of one of the variables you could choose. I'm just going to choose to do this, to rewrite it, basically solve for x. And the second thing it tells you is that you're going to take the derivative of the other formula. So I'm going to take the derivative of this, but I'm going to take the derivative of that until I plug something back into there, and this is just in terms of just a single variable. So let's see, let me just see what I get. So like I said, I'm going to solve for x, so I would first add y to both sides. So now I've rewritten this formula in terms of y plus 144. So it's exactly the same equation as the difference formula, it's just written a little bit differently. The second thing I need to do is take the derivative of p. But before I do that, I need to plug in this part, because since both of these are equivalent, I could replace that x for this new value. So this new value, what's inside the parentheses, is going to replace this x. So this x is going to expand, and everything else is going to stay the same. So I'm going to have p is equal to my new x value times y. And that new x value is this value, this right here, y plus 144, I'm sorry, 144. Now I could take the derivative of that. So let's go ahead. If I wanted to take the derivative of this, I need to simplify that. So I'm going to rewrite this as, I'm going to distribute this y to both of these two terms, and I'm going to get y squared plus 144y, and then I'm going to take the derivative of that. So p prime is going to be equal to, what do I get when I take the derivative of that? That's right, I could use the power rule here, and this is going to turn out to be 2y, and the y is just going to drop, and I'm going to have plus 144. That's my derivative. What do I do with that? Well, what we typically do here is we since we're trying to minimize, right? How do we find a minimum value? Well, we set this equal to 0 and we find our critical points for the first derivative. And that could potentially be a min, or it can be a max. So I'm going to set this equal to 0, 2y plus 144, and I'm going to solve for y. Well, if I solve for y, I'm going to subtract the 144 from both sides. That's going to add up to negative 144 is equal to 2y. And if I divide both sides by 2, I get that y is equal to, what is 144 divided by 2? Think about it for a little bit. That's right, it's negative 72. That's my y value. Now, I need to decide whether that, in fact, is a minimum value. So what I could do is I can draw my number line and test to see if negative 72 is a minimum or a maximum. Hopefully it's a minimum. So I'm going to have my test points for this region and that region. And what's a good test point here? Let's say negative 80 and positive 80 maybe? Or, yeah, positive 80. Or let's see, how about 0? Right, that would be easier. 0 would be over here. And those two numbers go into my first derivative. So if I plug in a negative 80 here, negative 80 times 2 is going to be larger than 44. And since it's negative, this is going to be negative. So I'm going to be decreasing from here to here. If I plug in a 0 here, I'm going to get a positive 144. So I'm increasing here. When I change from a decreasing slope to an increasing slope, that indicates a minimum. So yes, this number is the minimum y value. So the first number would be y is equal to negative 72. So what would be the x value? What would be the other term? Well, we know that the difference is 144. So this x value would be 144, right? 144 is equal to the x minus the negative 72. So if a negative times a negative is a positive, so if I subtract both sides by negative 72, I get the x value. And that is my answer. I'm going to leave that to you. You can figure that out, I'm sure. But that wraps it up. This is the essence of an optimization problem. Hope you liked the walkthrough, and if you want to see more walkthroughs of math problems, go to mastermathcourses.com.
So that wraps it up. And if you haven't signed into YouTube, oh my goodness, you're going to have to waste hundreds of milliseconds. But don't forget to subscribe to this channel. Just sign in, dude. It's worth it. It's worth your time. You can ask a question. We could follow up with another video.